So in this video, we're going to go over right triangles. And this may be one of the most applicable things you ever learn in math, are triangles, because there are so many applications to it. Now, I may be saying that because I have a background as a structural engineer, and pretty much anything structural out there has to do with triangles. But for me, this is probably the best thing that you can ever learn. So as far as right triangles go, we're going to talk about the Pythagorean theorem. And then we're going to talk about our trig functions. And these all help us determine sides or angles of a triangle, which, like I said, is extremely useful in the real world. So let's go ahead and just start with the Pythagorean theorem. All right, so this theorem says when you have a right triangle, the length of the vertical side is A, length of the horizontal side is B, and then the length of your hypotenuse is C. This is your hypotenuse. Ooh, I did not spell that right. Hypotenuse, like that. And that's always the side that connects your vertical and horizontal side. So the two sides that make up your 90 degrees, opposite of that is your hypotenuse. Now, the Pythagorean theorem says that the length of A squared plus the length of side B squared equals the length of side C squared. So this is going to be extremely useful when you have a triangle like this, and say you know that this side here is 9 inches. This is 12 inches, but you don't know the length of your hypotenuse, so you need to find C. You can go ahead and plug these numbers into this equation for the Pythagorean theorem, and you can solve for C. So A we know is 9 inches, so 9 inches squared, plus B we know is 12 inches squared equals C squared. So 9 squared, that's going to be 81 inches squared, plus 144 inches squared equals C squared. Now 81 plus 144 is 225 inches squared equals C squared. Now, just as we learned in the previous video, to get rid of your square, you just take your square root and that cancels that out. So take square root of both sides and you'll get 15 inches equals C. So we just solved for the missing side of that triangle. Now this also works if, let's say we know this is 25 inches and we know that this is 15 inches and we need to find side B. Again, you just take what you know and plug it into this equation. So you use the Pythagorean theorem. So A squared plus B squared, which we don't know, so we'll just leave it as B, equals C squared, which is 25 inches squared. So then you can go ahead, 15 squared is going to be 225 inches squared, plus B squared equals 625 inches squared. And then you can subtract 225 from both sides. So you'll be left with b squared equals 400 inches squared. Again, to get rid of that squared, you just take the square root of both sides, and you get that b equals 20 inches. One thing to notice when you're doing your units, you square your number and then you also square your units on that as well. And then same goes for when you're taking the square root. Not only do you take the square root of your number, but you take the square root of your units as well. So it's just kind of like your units are a variable. You do the exact same thing to the variable that you were doing to your coefficient. So that's how units work out on that. And then one nice application of this is finding distance between 2 points on a graph. So let's say you're given the points 0, 3, and -1, -1. Sure, we'll go with that. And you're asked to find the distance between these points. You might be staring at this going, how in the world am I going to be able to find the distance between those 2 points? Well, let's just go ahead and plot it and see what happens. So let's go ahead and plot 0, 3. So 0 in the x, we're going to stay here, and then 1, 2, 3. So that's our first point. And then -1, -1. So that's our second point. And we need to find this distance here between those 2 points. What we've actually got, if we connect these out, is a right triangle. So you can see that right there. So we've got our vertical leg and our horizontal leg, and then our hypotenuse. So the distance between those 2 points is actually our hypotenuse. So if we can find this change in x and this change in y, we can use a Pythagorean theorem to determine the distance between those 2 points. So this would be like our A, and this would be like our B. And this would be like our C. All right, now once you have it graphed, you can actually just count the distance. So for delta y, we're gonna have, let's change color one more time. Go ahead and use purple. So you're just gonna count. You're gonna start here and you're gonna go 1, 2, 3, 4. And then for x, we start here and we go over 1. Now, another way you can do that is by using these points right here. So it's just going to be the change in your x values and then your change in your y values. So again, that's going to be total distance. And so all this is going to be positive. So it's going to be 0 plus 1 is going to be equal to your delta x. And then 3 plus 1 is going to be your delta y. So as you can see, delta x equals 1, delta y equals 4, which is exactly what we got down here when we counted them. So either way, whichever works for you, whatever you understand. But now we know 2 sides of our triangle, and we can go ahead and solve for our hypotenuse, which is our distance, which is what we're being asked for. So again, a squared plus b squared equals c squared. But in this case, this is going to be delta x squared plus delta y squared equals our distance between those 2 points squared. So it's going to be 1 squared plus 4 squared equals d squared. So 1 plus 16 equals d squared. So 17 equals d squared. Take the square root of both sides, and you're going to end up with 17 is prime, so the square root of 17 equals d. Now, if you want a decimal value for that, you can go ahead and plug that into your calculator, and it'll give it to you. All right, so that's just one of the nice real world applications of Pythagorean theorem. And then finally, the last thing that we're going to go over for right triangles is our basic trig functions. So there's these trig functions. There's the sine, the cosine, and the tangent. So if you have your right triangle, and let's say we're looking at this angle right here. In relation to this angle, it's got an adjacent side. It's got a side opposite to it. And then, of course, it's got its hypotenuse. All right, now it's really important that you identify which angle you're talking about, because if we have our right triangle and we're looking at this angle, this then becomes your opposite side, this becomes your adjacent side, and this still stays your hypotenuse. Your hypotenuse is always your hypotenuse, but the adjacent and opposite change based on which angle you're looking at. So we'll call that angle theta. All right, so we know that the sine of theta is equal to the opposite over the hypotenuse. The cosine of theta is equal to the adjacent over the hypotenuse. And finally, the tangent of theta is equal to the opposite over adjacent. All right, so one way you can remember all of this, because it can seem kind of hard to memorize, is SOHCAHTOA. All right, so this is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. So for each of these little acronyms, it's going to be like some letter equals a different letter over that other letter, just like that. So again, until you have it memorized, that's the best way to remember which sides go with what trig function. Again, it's SOHCAHTOA. All right. So what can we actually use these for? Let's go ahead and look at an example here. Let's keep those up there so you can see them. If we got a right triangle, and we know that this angle here, theta equals, let's just say 25 degrees. And we know that the length of this side here equals 10 feet. All right. Now we want to find our other two sides. So we need to find our hypotenuse and then this distance y. All right. So we know which side in relation to this theta. We know our adjacent side because it's the side that's touching that theta. That's not the hypotenuse. So that's our adjacent side. So we know adjacent, and we need, let's go ahead and start with our hypotenuse. So which one of these up here has both the adjacent and the hypotenuse within it? It's going to be our cosine. So we're going to go ahead and set up that equation. So cosine of theta equals adjacent over hypotenuse. And so cosine, we know our theta is 25 degrees. Our adjacent is 10 feet, and we don't know our hypotenuse. So we're just going to go ahead and leave that as, we'll just use a capital H for hypotenuse. Now you just have a typical equation So you're going to times both sides by h. So you have h cosine 25 degrees equals 10 feet. And then divide both sides by cosine of 25 degrees. So then you'll get h is equal to 10 feet divided by cosine of 25 degrees. And when you plug that into your calculator, you get that your hypotenuse is 11.03 feet. So now we know the length of our hypotenuse, and we know two sides of our triangle. So at this point, you can either use the Pythagorean theorem, or you can use another trig function. We'll go ahead and use another trig function, just because that's what we're learning right now. So now we know, let's go ahead and erase this. Now we know you can either use your adjacent side or your hypotenuse, it doesn't matter. I'll go ahead and use the adjacent side again. And we need our opposite side. So we come back up here and boom, tangent's got opposite and adjacent. So we're going to go ahead and use our tangent function. So tangent of theta equals opposite over adjacent. So tangent of 25 degrees equals y over 10 feet times both sides by 10 feet. And you'll get that y equals 4.7 feet. So we just solved that triangle using our trig functions. Now this is a little bit trickier to grasp or wrap your mind around, but the more you practice it and the more you do it, the easier it'll become. If you're having troubles though, feel free to send us an email or reach out to us and we'll be able to get you the help that you need.